So these minerals I talked about are going to be, they're going to diffuse across a concentration gradient from some place that has more concentration to some place that has less concentration. That's what this slide shows. So here you see, for example, the inside and the outside of a cell. And you see sodium, you see potassium, those like triangles. All right, you see oxygen and carbon dioxide that are dissolved in the blood. So we're going to focus on sodium and potassium here. The inside of the cell is more negative than the outside of the cell. We're going to learn why, but there is a machine called an oscilloscope that can measure the called transmembrane potential, the difference in the electrical signal inside the cell and outside the cell. And it's a signal that is going to, you have two little nodes, you put one inside of a cell and one outside of a cell, and you measure the difference between the two environments, and that's going to indicate the potential to you, which for a neuron is negative 70. So every neuron, the inside of every neuron is about negative 70. That is the resting potential for a neuron, negative 70. And that's measured with a machine called an oscilloscope. Okay, and that is OSCILLOSCOPE, and that tells us that the inside is negative 70. Here you can see what an oscilloscope looks like. It's just going to be a machine that's going to put a node on the inside of the cell and one on the outside of the cell, and it can measure the difference between these two. Now, one of the reasons that the inside of the cell is more negative than the outside of the cell is something called the Sodium Potassium Pump. Now, the Sodium Potassium Pump is going to exchange two potassium ions. An ion is like the smallest possible unit of it's a very small unit of any given substance, like sodium, potassium, any mineral substance, any substance. It's an ion. And the sodium potassium pump is going to, it actually requires energy, requires a lot of energy. It is a very specialized protein structure on the cell membrane that allows two potassium to come into the cell and throws 3 sodium outside of the cell. Yeah, sure. I always repeat myself 3 times. So if you don't get it the first time, we'll get it the second or third time. And this, I always repeat the hard concepts 3 times. Okay, that helps with.
I have a question.
Yeah.
Are these videos going to go on YouTube?
They're going to go on YouTube. Yeah, yeah. So the sodium potassium pump is going to exchange 2 sodium. It's going to allow 2 sodium to come inside the cell, and it's going to kick it's going to allow 2 potassium to come inside the cell, and it's going to kick 3 sodium out. Every time it does this, it's going to require a little bit of energy. So to maintain the resting potential of neurons takes a lot of energy. It's one of the many, many reasons our brain requires so much energy. Now, here's the deal, and this is why students get confused here. Sodium is a positively charged ion. So just an ion of sodium, it's positively charged. Potassium is a positively charged ion. So how is it that you're exchanging positively charged for positively charged and you're coming up with a negative? How is that possible? It's a matter of, it's the ratio. Is money positively charged to $1? Does that have a positive 1 or a negative 1 on it? Positive 1, right? How much is a nice pair of Christian Louboutin sneakers cost? $1,000, $800, right? Okay. So we're going to talk about how do you get a pair of Christian Louboutins? You buy it. You get the money, you buy it. Okay. So let's say you worked at McDonald's. Let's say. Would you be getting money in your bank account? Would that money have positives, pluses attached to it? Okay, so if you had a job at McDonald's, actually New York City starting salary is not so bad, but let's say you lived in a country that has, a part of the country that has no labor laws, and you made $8 an hour at McDonald's, and then you went to buy a pair of Christian Louboutin shoes. It would take a while probably, right? But let's say you just worked for McDonald's for a few months and you went to buy a pair of Christian Louboutin shoes because you just wanted them. Most likely, would you be taking out some debt to do that? Yeah. So all of a sudden, the positive money that you got in your bank account and the positive money you're giving to Christian Louboutin would turn into a negative. Isn't that right? Same thing here. Okay? Because you're always losing one positive charge. You're taking in two, but you're losing one. And over a period of time, it makes the inside of the cell more negative. So it's because of that ratio, it's because of that, the way that works. Always taking in two positives, but always letting go of three. And that's how it works in personal finance as well. If you're taking in less money than you're spending, you're always going to be at a deficit. Same thing in this kind of example. So even though sodium and potassium are both positively charged, it's the way that two potassium are always coming in and 3 sodium are always going out. So it's leaving the inside of the cell more negatively charged than more positively charged. Do you get that? That is the function. Okay, you're shaking your head. I'll get to that again. So the sodium potassium pump maintains, or it helps to maintain, the resting potential of a cell. That's its main function. Sodium and potassium are very important elements that are minerals that are involved in signal transmission. There's a lot of it in our system. We need both sodium and potassium in order for the brain to function properly. And in order for the brain in order to maintain the cell's resting potential, which is just the natural potential, the natural state that a cell is at, every neuron is around -70 at any given time. That is just the way it is. In order to maintain that, you need the sodium-potassium pump exchanging more, getting rid of more positive charges than taking in. It has to be getting rid of more than it's taking in. If it does that, it maintains the resting potential. Are you with me there? Okay. There are going to be many sodium-potassium pumps around the cell membrane. These are very, very complex proteins. And what they do is they might attach to 2 potassiums. They change their conformation. They're going to move around, right? They're going to release 3 sodiums, and then they're going to do it over again. And that's going to take energy every time. That's the sodium-potassium pump. On the test, you need to know that it helps maintain the resting potential.